This time of year means handmade gifts, and this one is extremely useful and practical. A cutting board for an undermount kitchen sink. It's sturdy and held into place by the raveted and flanged edges of the board. It is also sophisticated with breadboard features that accommodate wood movement. I used maple for its hardness and closed grain. I'll turn on X-ray so you can see the inside joinery. There's a short tongue and 3 long tenons, and there are 3 wood screws and slotted shank holes to allow expansion and contraction. And the breadboard construction helps to maintain a flat cutting surface. You should start this project with a simple model of the counter's sink opening. I'll copy the board and show how this fits in this sink. And here in this example, the sink corners are slightly rounded or radiused, so it's necessary to match this in the cutting board corners. I'll complete this project in 2 separate video phases. The first will get an overall shape of the components, and the second will show the detailed joinery and wood screw implementation. So to start out on the modeling, I want to capture the actual radiused edges of this sink opening. So I will select just this end and then do a control copy that selection, close the component, and then place that, use a control V or option in the Mac, and here is that copied end of the sink opening, and I can knock out the bottom parts of these graphics, and I don't need those arc centers. I made this cutting board 10 1/4 inches wide. So I'm going to bring this back 10 inches, show a guideline here 10 inches, and an extra flange will be added later of 1/4 inch, giving me an overall 10 1/4 width. So this is the face that actually fits inside the sink, and it's radiused already, you can see, and I'll pull that up 3/8 of an inch because the cutting board is 3/4 of an inch, so half the cutting board thickness will fit into the sink. And the overall width with the flange out over the lip of the counter, that makes it 10 1/4. So I've set another guideline there to create the full size of this plate. And I'll just add this extra flange out here for starters, and then use the push-pull tool to pull that up another 3/8, giving the total thickness of 3/4. Bring a couple lines all the way back to the corner, and in this direction, and now we've got a full thickness of the cutting board. I don't need these shapes here on this surface. Also, I need let me complete this with some little vertical edges here. And I don't need that edge there. But there's just a little more cleanup. Go to X-ray and there's some edges inside here that aren't needed. While I'm at it, I probably just should smooth out these vertical things around the rounded corners. Using the eraser with the control key. Except there I actually deleted something. There we go. Okay, that looks pretty clean. Round in the back. And I do need to create the little flange on the top and bottom. So out 1/4 of an inch here. And we've got the basic shape of the cutting board, full size. And I want to put a little thumbnail molded edge on the top surface, and I'll make that a 1/4 inch rounding. Let me put some guidelines in here, 1/4, so I can create the little profile. I'm going to come down vertically, just 1/16 too much. I'm going to go a 32nd, and then grab the arc tool That looks pretty good. And with the follow me, I can cut this molding around the 3 edges. I guess you could go this right edge as well, but I'm just going to go the 3 edges, leaving as much surface for cutting. And there's a little bit of cleanup needed here. Here I can smooth out that edge with the eraser and a control key. There's another edge that can be smoothed. Now we don't have the breadboard at this stage. I haven't made any components yet. This is just all graphics without real pieces here. And I want to start making the components. And the breadboard, I'm going to make that 2 1/4 inches width. So off the edge here, that means 2 inches because the flange is 1/4 inch. So there's 2 inches on the underside. Do the same up at the top breadboard. And I need to slice off the breadboard shape, so I'll create a boundary here, a fence, a cutting surface. Okay, that's good for this end, but let me do the same at the other end. I'm using the arrow keys a lot to force my direction in the red and green and blue axes. Okay, so we're ready to make components. But no, I'm not ready to make that a component yet. I need to, that cutting surface didn't cut through, and I need to do an intersect here. Intersect with selection. I selected everything. Now I've got it. Now I've got a full slice, and I can select out the bottom breadboard, make that a component called breadboard. That will require a little cleanup. And I don't need these graphics up here as I'll just copy the existing component, flip it, and put it at the other end. But first, I'll make a component of the cutting surface here, the main cutting surface. And that grain is going vertical. Two components. That's all that exists in this piece. But I'm going to separate it out here and check it over and do some cleanup. There's a face missing here. Let me draw over an edge and close up that face. Knock out these extra graphics. Looks pretty clean at all the corners. That looks good. I can erase the copy and bring a copy of the breadboard up and do an inspection there and knock out any extra graphics. Okay, that looks good. And I might as well just connect this to the other end. So you get the move tool here. Oh, let me flip it first. Flip it on the red axis or green axis. And come down and connect this back here. And now we've got our arrangement of all the components, and what's left is the joinery, which I'll do in the next video.